I'm going to ask the volunteer to read the definition 1 about absolute maximum, absolute minimum, and also definition 2, local maximum and local minimum values. Who want to read for us? Any volunteer? Dylan?
Definition 1. Let C be a number in the domain D of a function f, then f of c is the absolute maximum value of f1d if f of c is greater than or less than f of x for all x in D. Absolute minimum value of f1d if f of c is less than or equal to f of x for all x in D. Definition 2. The number f of c is a local maximum value of f if f of c is greater than or equal to f of x when x is near c. Local minimum value of f if f of c is less than or equal to f of x when x is near c.
Very good, very good, okay? So, we are going to look at 4 definitions, okay? So it says absolute maximum, okay? So let C be a number in the domain D of a function f, okay? So I'm going to draw a picture. So for example, this is domain D, okay? It's a interval, okay? It's an interval. Say this is a closed interval. Say for example. And this is a graph of the function f, okay? So y equals f of x, okay? So this is just an example, okay? Just an example, okay? This is a domain D, okay? Alright, let C be a number in the domain D, means C varies between A and B, okay? So then we say f of C is the absolute maximum value of f on this domain D if f of C is greater than or equals f of x for all x in D. So how to understand f of C is greater than or equals f of x for all of the x in D means what? For all of the x values that we can choose, okay? This f of C is what? The greatest value for f for all of the x in D, right? So now from the current graph, do you see a highest point on this curve? Guys, do you see a highest point on the curve? Do you see that? About here, right? About here. So this is going to be our what? C value. Why? Because from the definition of the absolute maximum value, absolute maximum, okay, we can see that when x equals c, this is what? F of c, right? This is a function's value f of c. F of c is greater than or equals what? All of the f of x. Say for example, this is x. This is f of x. F of c is greater than or equals f of x for all x in D. Guys, do you see that? Or how do you understand the absolute maximum value of f? If we see a highest point on the entire graph, right? And this point has what? X coordinate c, y coordinate what? F of c. So if we encounter a highest point on the graph, we say this function f has what? The absolute maximum value f of c at when x equals what? C, okay? Yeah, so absolute maximum value of f at when x equals c, okay? So when x equals c, right? Is this easy to understand? Absolute maximum, the highest point on the graph, that it has the biggest value for f. So that's called absolute maximum, you guys. Well, similarly, how do you understand the absolute minimum value of f? If we have what? Oh, if we have a number c in our domain, such that what? f of c is less than or equals what? F of x for all x in D means what? Oh, if we have a lowest point on the graph. Now, from this curve, do you see a lowest point on the graph? Do you see? Here, when x equals a, okay, well, then we say f of a is the absolute minimum value. Why? Because this point is what? The lowest point on the entire graph. Do you see that? And see, this lowest point is occurs at what? The end point when x equals a. Yes, it may, okay? So that means for absolute maximum or absolute minimum, no matter where the c is, it could be in between of the curve, okay? Or this c may be what? This highest point or lowest point may occur in between of the curve, or it may occur where? At the end point. If the end point is included in the domain, say this is a closed interval, okay? So we say this point has coordinate what? A, f of a, right? So f of a is the absolute minimum value, okay, when x equals a. Guys, do you see that? This is absolute minimum value, absolute maximum value. Just see what is the highest point, what is the, lowest point on the graph, okay? The y-coordinate give us the extreme value. The x-coordinate give us what? When x equals where? It gives us the extreme value. Both of the absolute maximum, absolute minimum value in total, okay, in general we call them extreme value, okay, extreme value. So that's good for the maximum minimum values? Absolute. Now let's see. Local maximum, local minimum values, okay? So just now Dylan already read. We say this number or this value f of c is a local maximum value of f if what? F of c is greater than or equals f of x when what? X is near c. Does it say for all x in the domain? No, right? So local maximum means what? Say for example, guys, let's look at this picture, okay, this graph. What does local maximum mean? When x is close to this, say, number D, okay? Oh, where? I think this is the highest point, right? So I would say this is D. So for example, this is D. This is D, okay? This is D. This is some point x close to D, okay? And then local maximum. How about this B? What do you think? See, local means what? When x are, see, these x are very close to what? B and or D, because this is also could be x, okay? X is near B, x is near D, what? The f of B and f of D is greater than or equals f of x when x is near C. So that's why we have local maximum f of B and f of D. Guys, do you see that from the graph? I'm using this graph directly, okay? So this means local. Local means when x is near C, okay? Yeah. So that f of C is greater than or equals those f of x, okay? Well, the thing is, how do you understand near C? This near C must be what? In both directions. Okay, now guys, I'm going to ask you a question, okay? So this is A, right? This is A. This is B, C, D, and this is E. I would say that this is X, okay? I would say that this is F, okay? This is F. The domain is from A to F. See, give example, okay? It's a closed interval from A to F. Well, just now for the local maximum values, we can tell, oh, this is a local maximum. This is the local maximum with locally highest point, right? Local highest point. Can we say f of f? Well, let me change to a different letter, okay? This E and I would say H, because you don't want to use F and F, okay? So can we say f of f is also a local maximum? When x is near C from both directions, this is our interval. So we don't have x is close to h from the left-hand side, but do we have any other x to the right of the h? No. So here, this near C means what? Near this h from both directions. Now, this f of h cannot be considered to be our what? Local maximum. You guys understand that? It's not like the absolute maximum. Absolute minimum could occur at its endpoint. However, for local maximum, local minimum, can the local maximum, local minimum occur at its endpoint? No, because at its endpoint, we only have x values to one side of the endpoint, but we don't have the on the other side. So f of h is not a local what? Maximum. Similarly, can we say f of a, this endpoint is a local minimum for the graph? Can we say that? No, either. Why? Because f of a, this point is what? An endpoint, okay? At the endpoint, there's no local maximum nor local minimum. You guys understand? Okay, alright, very good. So, what does local minimum mean? When x is near C from both directions, okay, in both directions, same thing, okay? Okay, when x is near C in both directions, f of C is the smallest in, when x is near C, okay? So now from the graph, can you tell how many local minimum do we have? Have you found any local minimum? Do you see the f of C here? Right, this is a local minimum because locally this point is the lowest point, right? How about another point? F of E, what do you think? Also what? Local minimum, right? Can we say f of A is also a local minimum? Can we say that? No, because it occurs at the end point, okay? So local minimum, f of C, f of what? E, okay? And then what is absolute maximum value? F of what? D, right? This is D. What is the absolute minimum value? Lowest point on the entire graph, f of A. Guys, everybody clear about this concept? Okay. So these are these concepts, okay, as I said, I would strongly suggest you read your textbook as well, okay, because textbook also explains very clearly about this definition. You want to go over that textbook as well, okay. Alright, so these are the definitions. Now, let's look at the practice question. What's up?
So for that graph, is the absolute maximum also D?
Yeah.
Right, okay.
Absolute maximum is f of d, right? Because it occurs at when x equals d. The absolute minimum is f of a because this point is the lowest point on the entire graph. Okay? And the local minimum, there are two of them at C and E. Local maximum at what? B and D. You see, locally we do not consider the endpoint. No. Very good. Alright, so let's look at this practice question, okay? Use a graph to state the absolute and local maximum and minimum values of this function. Okay, yeah, there's only one n there, but this is function, okay? I'm going to, this is 0, 1, 2, 3. 0, 1, 2, 3. 1, 2, 3 is here. Sorry, 3 is here, 4 is here, this is 5, okay? Ugh, it's so hard to, this is 0, okay guys, this is 0. This is 1, okay, this is 1, this is 2, 3, 4, and 5, okay? So the graph looks like this. Open circle. However, at x equals 1, this function is defined. And then f of 1 equals what? 3. Okay, f of 1 equals 3. Okay. So the left endpoint is closed. Right endpoint is what? Open. Find absolute maximum, absolute minimum, local maximum, local minimum. I'll give you a couple minutes to answer these questions. Think about it. Write down your answers at first. Then we'll check, okay? This is challenging, okay, because we have so many holes and endpoint closed then open, okay. Let me ask some of you guys to answer the question. Yeah, the graph start from here. Absolute maximum. Who would like to answer this question?
5.
5. Okay, so how do we write it down? This is something that we should pay attention. Yes, 5 is absolute maximum value. And it occurs when x equals what? 1, 2, 3, and what? 4. So when we write it down, we write like this. F of 4 equals what? 5. See, it tells us when x equals 4, this absolute maximum value happens. And what is absolute maximum value? It is 5. Right? Very good. Everybody agree with this, right? Absolute maximum. What is absolute minimum value? Do we have any? Can we say this is absolute the minimum value? And how about this point? This point, the y value does not even, it's smaller than 2, right? We can tell At this endpoint, it looks like it's the smallest value, but is it defined?
No.
No. So no absolute minimum value.
That's a trick.
Yeah. See, there's no lowest point on the graph. This point looks like it is minimum. However, it is undefined.
Because you can always say the smaller number.
So no absolute minimum value. No. Right, Tyler? You see, this is 2. This is 1, right? This is at 1. Okay. All right. Local maximum. Can we say f of 1 equals what? No, it is not defined, right? Can we say f of 1 see, f of 1 equals 3 is not local maximum, right? So we don't count this. Now we have a local maximum, what? F of 4 equals what? 5. You know, this is absolute maximum. It is also what? Local maximum. So we say f of 4 equals what? 5 is a local maximum, right? Now let's go, we always check from the left to the right, okay? Left to right. So this top, no, okay? And here, this I would say this is a little mountain, top of the mountain. Oh yes, local maximum. How about here? Can we say f of 6 is also a local maximum?
Yes.
Yes or no? Yes. Why? Check. When x is close to 6 from both directions, right? F of 6, this f of 6 equals what? Equals 4 is indeed the highest point locally, right? You guys do see that? Even if it's not continuous, but when x is close to 6, near 6 from both directions, this f of 6 is what? The highest point. So yes, local maximum f of 6 equals 4. Right? Alright, local maximum. Let's check from the left to right. Can we say f of 0, this is a local minimum? Remember? No, we say any point cannot be considered as local minimum. Okay, local minimum must have what? Well, x is close to this, c value from both directions. Okay, so I want to say no, that, okay. Can we say f of 1 equals 3 is a local minimum? See, when x is close to 1, this point is even less than, lower than this point, so no. How about here? What do you think? Yes or no? Yes. So f of 2 equals what? 2, right? And then, how about here? In both directions, when x is close to 5 from both directions, is this point a local minimum? Yes or no? Yes. Just look at it. This mountain goes downward. Okay, see? Here it is a local minimum. This is also local minimum. So f of 5 equals what? 3. Right? Alright, so there are no other local minimum. It's really challenging because many holes. So far so good for this question? Okay, so let's move on to the other questions, okay? These two examples. Sketch the graph of f by hand and use your sketch to find the absolute and local maximum and minimum values of f. Okay, so question A and question B. At first, I'm going to let you guys try to sketch the graph of them at first. Then from the graph, we can tell the values. Okay, so the first one, trig function, y equals sin of x, x is between 0 to pi over 2. Do you know how to graph the sin function? You know? Start from what? Start from origin, right? Every 2 pi is a circle, right? So, but our domain for the function is only from 0 to what? Pi halves, right? And then 0 is included in our domain and pi half is not. You guys agree with me? What is a y value when x equals pi over 2? 1, right? I'll give you 1 minute to write down your answers. Who want to answer this question? Dylan?
Absolute maximum is f of pi over 2 equals 1. Oh,
Well, it looks like it's the highest point, but it is not defined on pi over 2, right?
so it's
None. I would say none or NA or whatever. Okay, so none or NA, whatever. Dylan, still you. Absolute minimum value.
that would be f of 0 equals 0.
Yes, very good. Do you have local maximum? No, see there's not even, no, we don't even have a mountain, right? So none. Do you have local minimum value? No. This one is absolute minimum value, but it's at the end point, right? So no. We do not have local minimum either. Question B. Graph y equals 1 minus square root of x. Think about it. What is the domain for this entire function? What is the domain? We have a square root, so this x value must be what? Zero to infinity, right? Because there's no negative values for x. And how to sketch the graph?
One in like the,
Looks like this, right? How did you get that?
oh, just because the negative sign flips it.
This is a regular y equals square root of x, right? Remember we did what? Transformation, right? So what is y equals negative square root of x? You guys, right? But we need what? 1 minus square root of x. So we have to shift this graph what? 1 unit up. You guys, do you see that? This is y equals 1 minus square root of x. Do I have a red pen? I hope so. I don't know why it doesn't show on the screen. From my side, I can see I'm having a red curve. You see this thick one? But I don't know why on the screen it doesn't show it is red, okay? Well, from here, when we're recording, it is a red curve, okay? Doesn't matter, okay? So, guys, you see this is our graph, right? This is our graph. Y equals 1 minus square root of x. Now answer the questions. want to answer this question? Sammy, you want to try?
It's sort of a last graph, I don't really want to do it.
Absolute maximum.
It's going to be 0.
What?
Well, I mean, it's at x equals 0.
X equals 0, but how do we write it? Remember,
Oh, and
f of 0, yes. You're right. It's
Right.
when x equals 0. But what is f of 0? 1. So 1 is the absolute maximum value. It occurs when x equals 0.
Right.
Okay, yes. Do you have any absolute minimum value?
I don't think so.
No, right? No, none. Oh, come on, from the school. Answer this too, please. Hello?
Hello, this is an important message from South Paraiso Community Home.
Oh, it's not about my daughter. Oh, every time when the school call me, fix me. Oh, okay. Never mind, okay? Do you have any local maximum? Endpoint? No. Do you have any local minimum?